Hi guys, in this series of videos we'll be looking at light as a particle and a wave, matter waves, and an exam style question.
So the classical model of light, as we learnt about in the video on the photoelectric effect, treated it solely as a wave. And now this was actually based on some pretty compelling reasons. So based on the fact that it undergoes reflection, which we're kind of clear on, but also diffraction and refraction, which are key properties of waves. Now these are things we're going to learn about later in a bit more detail, but we just need to kind of illustrate them quickly now. So here we can clearly see reflection. This black arrow here represents a light ray coming in, and it hits say a glass mirror here and then reflects. The key thing is that it reflects at the same angle it came in at. So this angle here is going to be the same as this angle here. Now this isn't completely something you'd attribute to light, because you could think of perhaps a particle coming in and bouncing off. So it's not completely evident that something that undergoes reflection is a wave, but certainly refraction and diffraction, which are two properties we'll talk much more about later, really kind of do sell something as a wave. So refraction, as we can see here, is where we have a light ray coming in. That's what this black ray is here, and it basically hits a boundary between two media. So this media here could be air, and this medium here could be glass. What we see is that many waves have different wave speeds in different materials. So light travels more slowly in glass than it does in air. What that means is that on moving into this slower, the medium in which it moves more slowly, light actually changes direction. So these purple lines here in both this diagram here and also down here are wavefronts. We talked about them briefly in our video on the photoelectric effect, saying how these wavefronts basically represent the kind of the crests of a wave. If you thought about looking down at the ocean and looking at waves, these would be like the crests of these waves. Just a way of showing basically lines of constant phase with these waves. Now these are all something we're going to talk about later. You don't need to worry about it too much for now. But refraction is basically where a wave moving into a different material changes its direction if it comes at an angle. And that's a very compelling property of a wave. But people still try to perhaps use ways of thinking about particles to explain why this happens. So it's not completely selling the fact that something is a wave if it undergoes refraction, but diffraction was entirely wave-like. And this is where, again, these are our wavefronts, where these waves basically pass through a narrow gap, and they spread out afterwards. So these are our wavefronts, our light's coming in kind of like this, or our wave in general. In fact, showing that light undergoes diffraction was a key thing that proved previously that light was a wave, and in fact justified this light model in the first place, and it's something we'll talk about later in the course. But what happens is, upon moving through this narrow gap, and again, both diffraction and refraction are properties of all waves, not just light. What happens is that passing through a narrow gap, the wave spreads out. So these are our wavefronts, it passes through a narrow gap here.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.